This is ship model. Is it visible to everyone?
Yes, sir.
Yes, sir.
Is it clearly visible, or it's according to your
Clear,
net?
sir.
I think it's according to your internet. If it is fast, then it will be clearly visible. Okay. So here it is. We have, it is visible that we have some compass to measure the angle. Are you able to see the readings? Readings which is actually mentioned on the graph, mentioned on the compass. Anybody please reply, is it visible? Okay. So first, do you have already our lab manual in soft copy form? Hello.
Yes, sir. Yes, sir.
Okay, so we have one observation table. Make that observation table, and we will start our experiment after that. This is the observation table we have. So actually, make that observation table. What is written here? Make the table on your notebook, and then we will start our experiment. So I am giving you 2 to 3 minutes to make this observation table. You all have drawn that observation table.
So just a minute.
Everybody drawn. Can I proceed further? Please reply.
Yes, sir. So just a minute.
Okay, okay. Take some time, 1 or 2 minutes, and draw that. And you should know all those things, that what is WS, what is X. I think it is written already in your lab work, just in the first page itself.
Yes, sir. Done.
Everybody drawn?
Yes, sir.
Okay. So this is the ship model and this is our movable weights. We have two set of movable weights. Okay. This is 1.2 gram. Each, 1.1 gram. 100 gram, na? Okay. 100 gram, then 1, 2, 3, 4. This is 600 grams movable weight. And this is 1, 2, 3, 4, 5. This is 50 gram each. So this is 250 gram movable weights. We have these two movable weights, and these are the these are the markings of X. We have X na in our observation table, that the distance of the movable weight from the crossbar. This is crossbar. This is crossbar. And these are the markings. Each marking is separated by 1 centimeter distance. Okay. So first we have, in the first column, we have WS. So WS is, please anybody reply what is WS?
250.
WS, what is WS first?
Weight of ship
Weight
model
of ship.
including movable weights.
Including. So 250 is movable weights, not a weight of ship model. WS is weight of ship including movable weights. First, you write that the ship model has. First, you write that we already have weighted the weight of ship model, and it is 3.780 kgs. This is only the weight of, don't write it in the observation table. This is only the weight of the ship. 3.780 kgs. Have you written? This is the weight of ship, not including, this is not the X, because, WS. Because WS is the weight of ship model including movable masses. So now I am going to put this movable mass at the distance of 3 centimeter. So now WS will become 3.780 plus 600. This will be WS. So anybody tell me WS?
$4.380.
Okay. So write that. So write that in the first serial number 4.3. What is that? 4.380.
80.
Okay. And write X is equal to 3 centimeter, because we have taken from here, this is the third, 1, 2, 3. Okay, so X is equal to 3 centimeter. Now theta. Theta is equal to, I think it is not visible to you, so I am dictating that it is 3 degrees. Theta is equal to 3 degrees. and we have another column of theta is equal to n theta. Write the value of n is equal to 1. So whatever the theta it is, the n theta will become the same. So it is 3 degrees. Now tell me the value of sine 3.
Sir, 0.0523.
Okay, so write in that column. And we will calculate metacenter height. Write the formula of metacentric height. Wm into x. I think it is already given in the manual. Metacentric height Cm is equal to Wm into x upon Ws sine theta. And we know that Wm, what is movable mass? 600 grams. Calculate the metacentric height and tell me how it is, what it is coming.
Sir, please repeat the formula.
We have already that formula in our lab manual.
Sir,
That
it is
is-
not written properly.
Okay, Wm into x. Wm is suffix, okay? So Wm is Wm into x
Yes, sir.
upon Ws sine theta.
Rate of the movable mass.
And Wm, write that value of Wm is equal to 600 grams.
Rate of the movable mass.
We have taken that 600 gram movable mass. That's why it is like that.
And just move it. Mass move.
Calculate that.
What are done? ये वाला नहीं होगा. 0.5, 0.05.
So 0.0786.
Now the next reading, write down the next reading. Just change the value of x is equal to 4. Okay. And now the theta will become 4 degrees. Ws is same. X is equal to 4. Theta equal to 4 degrees in this case. Calculate all those things. Okay. Now the third reading. X is equal to 5. X is equal to 5. Now theta is 4.5 degrees. X equal to 5. We have 3, 4, 5 now. Now x is equal to 6. Theta is 5 degrees.
नीचे हो सर वाला मोबाइल है सर वाला मोबाइल है वो हाँ सर का मोबाइल है
X equal to 7. Theta is 5.5 degrees. X equal to 8. Theta equal to 6 degrees. X equal to 9. Theta equal to 7 degrees. Now I am changing the weight. WM. So till now we have I think 7 or 8 observations. Calculate all the metacentric height according to that. In that WM will be same 600 degrees. Only the x and theta is changing, and according to that we have to calculate the n theta and then sin theta and then metacentric height.
आप अपना फोन में देखिए सब गया मेरा वाला
Sir, can you please show the entire setup once again?
Sorry, what you told? Repeat again.
Sir, can you show the entire setup once again?
Okay, okay, I'm showing you. This is the setup. This is the movable mass we have. This is the reading which is given on the that crossbar. This is the crossbar, and this is the compass where we are reading the theta. And the value of n is equal to 1 because the length of pointer and the radius of the that compass is same. That's why we are taking value n equal to 1.
So, sir, then if it was if it was 2 or something else, then in sin theta we will put n theta to get metacentric height.
Here n equal to 1 because the ratio of the compass and the length of the pointer is same. That's why the ratio is 1. So if accordingly if the ratio will become different, then we have different n. According to that we have to calculate sin theta.
Okay, sir.
Experimental procedure. Tell me. Hello, just tell me. So see, let us we have to design a ship, a boat. What is the capacity of the boat or ship which we have to design? And the distribution of the load means weight of the goods, man or some other things is not equally distributed in the boat or ship. That's why we are designing the meta center height. So up to that meta center height, you can shift the weight from one center to the one side. So we have shifted the weight from the center to the one side. Means the up to that the boat will not, that is the sink. So this is the purpose. So distribution of the load is always not equally. Somewhere is higher, somewhere some side is lower, but still boat should be, that is not sink. So metacentric height give the idea to which capacity we can shift the weight in one side. This is the idea. So similar here, we have chosen a small ship model having some its own weight, and we are shifting the weight from the center, means one-sided. So can it sink or not sink? That is the we have to check. This is the aim. So let us suppose the weight which we have shifted from the center is weight of the human, which are the sitting in the sea. So up to how much, that is the angle, up to how much twist, that is the ship will not sink. That is the idea or purpose of this experiment. So this is the design point of view of any ship, how much capacity you require, and accordingly that is the meta center is assigned. So this is, so have you calculated the metacentric height for the any load? Hello,
Yes, sir.
tell me how much you
Zero
got it?
point 0.0786 meter.
Meter for how much weight of the movable weight?
600 gram.
600 gram. So let us say numerically with some, it is that is not given in our syllabus, but with the help of the any textbook, you may check it numerically. Some examples check, is it satisfied or not satisfied? Am I right? So this is the metacentric, that is the height. Have you seen setup or not seen? There is a tank. In the tank, the water is fill up to some height, so we can insert the sheep. It should not water is came, that is the will come out. So this is our model. And shifting load is nothing but the goods, manpower like that. Is it correct? So calculation you can recheck or confirm with the help of the your examples. Am I right? And most, that is that today we have completed the metacentric height experiment. All of you write the lab report, and next week, that is that you should keep it with yourself, and later on we will collect it. If you have any query, then ask me.
सर लैब मैनुअल किस में लिखना है सर? A4 शीट में लिख सकते हैं या फिर कॉपी खरीदनी होगी?
Hello. First, you prepare for, that is the online classes view. Up to that is you write in the soft copy initially. Let us suppose you join the institute, then you can take the print out or simply submit in the institute. Let us suppose in the future institute will going to the reopen, then you again visit the lab. But right now you can write in the soft copy and keep with yourself. Later on, we will collect it or submit in the lab. Is it correct? First, you should write down
Okay,
the
sir.
soft copy. Is it correct?
Yes, sir.
And in the next group, we will take the different distance, yeah, different load. We can change both. distance or load or both, we can change.
कंफर्म कर लेते हैं
हाँ,
reading
yes.
में.
Yes, yes.
Have you calculated the metacentric height? Please reply. Yeah, for the
Yes, sir.
for the first reading, what is the metacentric height?
So 0.0786 meters.
0.07. Okay, take it in the centimeter. What is 7.85? I think.
Yes, sir.
So, like that, we have taken how much readings? 7, na? How many readings? 7 or 8?
So 7.
7 readings. We have first we will take that readings of in the observation table. After that, average all those readings, and whatever the average will come, this is our final metacentric height. Okay. So this was our observation, and this was our first experiment. We have seen and we have calculated the metacentric height by changing the movable mass and its distance from the crossbar. Yeah. Also, we can say that the center of that crossbar is in the center of the ship. So if we move from the center of the ship, the theta is changing. That's why the metacentric height is also changing. Okay, any query regarding this? Please ask. So, okay, I am taking attendance. Roll number 1,
Present, sir.
2,
Present, sir.
3,
Present, sir.
4,
Present, sir.
5,
Present, sir.
6,
Present, sir.
7,
Present, sir.
8,
Present, sir.
9, 10,
Present, sir.
11,
Present, sir.
12,
Present, sir.
13,
Present, sir.
14,
Present, sir.
15,
Present, sir.
16,
Present, sir.
13. Please confirm 13.
Yes, sir.
17,
17. Present, sir.
18,
Present, sir.
19,
Present, sir.
20,
Present, sir.
21,
Present, sir.
22, 23,
23 present, sir.
24,
Present, sir.
25,
Present, sir.
26,
Present, sir.
27,
Present, sir.
29,
28 present, sir.
28, 29.
Sir, 29 present.
Yeah, okay.
28
30.
present, sir.
Okay. 30,
Present, sir.
31,
Present, sir.
32,
Present, sir.
33,
Present, sir.
34,
Present, sir.
35,
Present, sir.
36,
Present, sir.
37,
Present, sir.
38,
Present, sir.
39,
Present, sir.
40,
Present, sir.
41, 42,
Present, sir.
43,
Present, sir.
44,
Present, sir.
45,
Present, sir.
46, 47, 48,
Present, sir.
49,
Present, sir.
50, 51,
Present, sir.
52, 53,
Present, sir.
54,
Present, sir.
55, 56,
Present, sir.
57,
Present, sir.
58, 59, 60.
Present, sir. 60.
Okay.
Okay, students. So today the first experiment is over. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
sir.
Thank you, sir.